So in this example, we're given the triangle ABC, with BD being the bisector of ABC, meaning that it bisects this angle ABC, this BD line segment, into equal angles. Okay, it divides this angle ABC into two equal angles. That's what bisector, angle bisector means. And FD is parallel to BC. These two are parallel, and also DE is parallel to AB. So AB is parallel to DE. Good. So now the first thing that you would do, you would write the given, you would write all that and define it, the reason for it as being the given. The next thing that you should see is that since we're talking about the bisector and equal angle measures, then we know for sure that ABD angle is congruent to EBD. Okay, so basically these two are congruent. And the reason being is, of course, the definition of an angle bisector. So now the third one that comes to mind, based on these parallelisms provided, we know for sure that we will have two sets of alternate interior angles created, right? Because these two are parallel and these two lines are parallel, and this BD, the one that's a bisector, also happens to be the transversal that is crossing the two sets of parallel lines. So for this reason we will have two sets of alternate interior angles. We will have this one, this set, and we will have this set. Okay, so these two sets define alternate interior angles. Okay, so we're going to say that angle CBD, angle FDB, and another set, angle ABD and angle EDB, are alternate interior angles. So the reason for that would be the definition, of course, of alternate interior angles. Definition of alternate interior angles. And keep in mind that these alternate interior angles need not be equal necessarily, right? Because there's still alternate interior angles even if we didn't have that parallelism, right? The alternate interior angles basically defines the position, right? The position. Basically you're talking about not in the same location like these two would be, but on the opposite sides basically of this transversal. Basically alternate interior angles will be on the opposite sides of the transversal, never on the same side. Okay, so this is the definition of alternate interior angles. Okay, so now the fourth part, the fourth statement, is to immediately see that these alternate interior angles are actually congruent. And why is that? Because we have two sets of parallel lines being crossed by a transversal line segment. Okay, so as we know, you can find these really quickly, CBD and FDB, or you can use that to find it. ABD is congruent to EDB. Okay, EDB. So the reason being, we can write it as parallel line segment AB and ED, or parallel line segments, I should say plural. So AB and ED. So this is a pair, that's why I'm using a comma here. And another set is what? BC and ED, right? So BC, comma ED are crossed or intersected intercepted, however you want to say, by transversal line segment BD. Segment BD. Okay. Now the fifth statement would be, so what are we trying to do here? To prove that BFDE is a rhombus, the first thing you should realize is a rhombus will have all four equal sides. So that means if we're talking about individual triangles, BFD and BED, we have to show that BF is equal to FD, and we have to show that BE is equal to ED. But before you do that, you have to determine that these two triangles are going to be exactly congruent. They're going to be congruent, right? Because if you're talking about a rhombus, then individual triangles, since this rhombus is divided in half, if it is a rhombus, it's divided in half, these two triangles would be congruent. So if you show that they're congruent, it will be really easy after that to get to this proof statement here, okay, to show that this is a rhombus. So how do we know? We already have two sets of congruent angles for these two triangles, don't we? We have this set and we have that set, right? As we defined in the fourth reason. Now, so that's already angle that we can use for congruence, but we need one more, and one more is going to be the side that they share, BD, right? So we're going to say that BD is congruent to itself, and the reason for that is the reflexive property of congruence. Okay, so this is the reflexive property of congruence. So guess what? Now we're ready to say that these two triangles are congruent. So BFD triangle is congruent to triangle BED. And the reason for that is the angle side angle postulate of congruence. Right? Angle, side, angle. Angle, that's one set. Side, which is shared, and the second set of congruent angles, right? Angle, side, angle. So now that we've showed that they're congruent, we can find the corresponding parts and set them congruent as well. Right? So basically what I'm saying is that the BF will be congruent to ED. Okay, because these are the corresponding parts, okay, of these two congruent triangles. BF is congruent to ED, and FD will be congruent to this opposite one, BE. And again, the reason for that is the corresponding parts of congruent triangles are congruent. CPCTC, the short version of that sentence. Now the eighth statement, we would use transitive property. So we have to now show that BF is congruent to FD. How would we do that? We have to use transitive properties. Remember that in the very beginning we showed that the ABD was congruent to DBE or EBD, right? Because these two angles were congruent by the BD being the angle bisector of ABC, right? So we know that these two are congruent. We already showed that in statement 2. Now take a look at this. Take a look at these parts here. We showed that ABD, we can use this statement, and we can use this statement, and use transitive property for these two statements. As you can see, ABD is the one that's repeated, right? So that means, since ABD is congruent to two different angles, that means these two different angles are congruent to each other, right? EBD is congruent to EDB, right? So we can set EBD is congruent to EDB. So let's see that graphically. EBD congruent to EDB. Good. As you can see, these happen to be the base angles of this triangle, right? And base angles will lead to congruent sides, two congruent sides, and that's exactly what we want. And the second set, of course, is, let's find that. How do we show that these two base angles are congruent? Let's find the transitive property again. So notice we can use this again, but this time the repetitive guy will be what? Okay, so notice EBD is going to be the same as CBD, right? Because this is a line segment BC, right? So just so you know, you can actually treat this as CBD. It's the same thing as EBD. Okay, so we can treat this as CBD. Okay, so in that case we can also say that this is CBD as well. It doesn't change the angle because the first letter doesn't matter in this case, so it's just CBD, right? So CBD is the same angle as if you were to say EBD, is congruent to EDB, right? So now the reason why I did that is because we're going to use transitive property with this statement right here, right? As you can see, CBD repeats, so ABD will be set congruent to FDB, and that's exactly what we want. But yeah, so you're going to use this statement and that statement. So CBD is the one that repeats, so we have to say ABD is congruent to, we have the CBD being repetitive, so ABD is congruent to FDB. FDB. Let's now graphically confirm. ABD, FDB. Good. So these are the base angles. Excellent. So now the reason being for that is the transitive property of congruence. Now, the next part is to see that as a result of these base angles being equal in each of these triangles, then the BF is congruent to FD. Okay, BF is congruent to FD. And also we have to say ED, well, BE is going to be congruent to ED. Okay, so BF is congruent, BE is congruent to ED, the one next to it, the side. And the reason being, in both of these cases of these two triangles, is that the opposite sides, recall that the opposite sides of congruent angles must be congruent. Okay, that's a simple reason, right? So basically, when we have the base angles being equal, the opposite sides to these angles must be equal as well in each of these triangles. Okay, because we already showed that the base angles were congruent. So now what can we show? So we showed that BF was congruent to ED, BF was congruent to FD, and BE was congruent to FD, and BE is congruent to ED as well. Right? So that already kind of shows that we have four congruent sides. But if you wanna dig deeper into it, if you wanna really show every single pair possible being congruent, you can. You can do that if you want. So you're going to use transitive property. So for example, you see BF being repeated in these two, so that means ED is congruent to FD. So let's just say that ED is congruent to FD. And let's find that ED, FD. Good. So this is the second set of adjacent sides, right? The first set we already had. BF and FD is right here. We already had that. ED and FD, so that's transitive property of congruence. Transitive property of congruence. So now let's keep going until we get every single pair of adjacent sides proven. We already showed BF, FD, we showed FDED. Now what about BE and ED? Well, we already showed that. So now let's show finally BE and BF, and then we're done, right? So BE and BF, how do we do that? So we need BF and FD. There we go. Okay, so we're going to use these two. And as you can see, FD is the one repeated, and that's the one that's not going to be included, right? So as a result, BF will be set to BE using the transitive property. BF will be set to BE. Perfect. That's exactly what we want. You see, I just wanted you to see how I can find it using the transitive properties and not just assume it that it's going to work, right? So BE will be set congruent to BF. Okay, so again, this will be the transitive property of congruence, same as line 10. That's why I'm using quotation marks. So now finally, we've showed every single adjacent side being congruent, pair of adjacent sides, and also the opposite side being congruent as well, right? This is probably more than enough, but just in case, you want to be sure that you show every single pair of sides is congruent. Okay, so as a result, we already showed all 4 congruent sides, so now we can just safely go to the last statement that we needed to prove. BFDE is a rhombus, and the reason being for that is a quadrilateral with 4 congruent sides. Okay, this is it. So thanks for watching. Hope this was helpful. See you in the next video.